Good morning, good afternoon, everybody. So the topic of the day will be the wireless technology and what are the use cases we want to cover when we talk about the industry or Internet of Things. So I'm Patrick Grosstedt. I work for Cisco as a technical marketing engineer. I'm part of the industrial IoT business unit. And let's see. So one of the challenges we are facing today when I'm meeting with customers is clearly, and once again, I want to reinforce the fact that I'm focusing on the industrial IoT. I'm not looking at the consumer market at all. But when we start looking at the IoT world here, the question is, when I want to deploy a solution and I want to use wire, there is one technology. Everybody's using wire with Ethernet. But as soon as you say wireless, there are so many technologies that we say that the flexibility and the agility of the IoT is the fact that you can move and you can be nomadic and you can reorganize. But the challenge is now when I want to deploy that for my vertical market, which one should I use? And this is clearly where we say there is no single size fitting all the requirement. And what we try to do at Cisco, it's we try to say, okay, how can we take a decision? How can we support customer partners and say, oh, this is what I want to do, and that's the technology I'm selecting, and that's how I need to deploy it. So what we try to do, we try to build a framework where people can now go through different steps, make sure that they can identify which industry they would like to deploy. From there, look at the use case, the specific deployment scenario, where is that deploy, which country, which region, how do you select the technology, and from there, look at the operational requirement. And clearly, this is the agenda, but at the same time, it's also the methodology we try to develop. And we want to make sure that we can share the information with our partner, with customer, and that's the reason for the Tech Field Day session. And I will go through a slide. Feel free to ask questions, and let's see if it works well or not. So the first one is, when we say industry, clearly I'm not looking at the IT department of whatever. I mean, we have different industry. We look at manufacturing and utilities, oil and mining, smart cities, transportation, distribution center. Clearly for us, when we say industrial IoT, we are not considering the IT department. We are looking at the operational department, and we want to make sure that we identify the key owner and the stakeholder for the OT department, how we can work with them, how we can learn their requirements. And what does it mean? It means we need to identify the use case characteristic. So let's say I want to go to transportation. What do you do on transportation? You look at, you may be looking, for example, let's take a train. I want to look at the passenger services. I want to look at the video surveillance. I will look at the communication-based train control. I will look at preventive maintenance. So clearly, we have different use cases. This is where we need to look at what are the requirements. And I can take any of the industry here. If I go to cities, I will be looking at the environmental monitoring, the pollution, the street lighting, the connected road. So once again, dependent of the use cases, the requirements are completely different. And that's why we need to connect that. At the same time, we need to understand who are the people operating the network and what will be the cost. Are you looking for managed services? Are you looking for investment, building your own infrastructure, and making sure that when we look at the solution and the full architecture, we don't only look at the access technology or the wireless technology. Remember that data are flowing on top of IP. They go from one location, which may be a small sensor, going up to the data center, and everything needs to be secure, everything needs to be managed, and clearly whatever we deploy as a solution for the what we call extended enterprise need to completely integrate with the rest of the strategy. At the same time, we are facing the fact that when you look at the industry, operation has been there for years. And that means you have an history. You need to look at legacy devices. You need to look at certification and compliance for each of the industry. And that's something we need to understand as well. Let's say you want to deploy a Wi-Fi access point for a refinery for oil and mining. You will need to be deploying a product which is certified for ATEX. how you protect the box from any incident. So that's clearly where, once again, certification, the history, the protocol need to be fully understood. What we have done at Cisco, if you want to get more about the industry segment, we have what we call the Portfolio Explorer, the Cisco.com. You can go there, you can look at all the use cases, all the industry, and see what kind of Cisco validated design guide we have already developed. So once you know the use case, you can pick whatever use case, and from there you will need to characterize what you want to do. So like, for example, you want to use a wireless technology, but what do you expect to do? Are you looking at building a backhaul connectivity? So for example, you want to do site to site, you want to connect the vehicle, the train, the subway to the track side, or are you looking at the access technology where, for example, if I look at Wi-Fi, I want to connect my mobile phone, my tablet, my laptop, my robots, my temperature sensor, you want to connect that to the network. So that's what we call the access technology versus the backhaul. At the same time, we need to understand what kind of device you want to connect and how many of them. We need to understand how much capacity you need for your network. When I say device type, or if you are looking at connecting, is the device offering a native interface? Like, for example, I can take my mobile phone today and I will be getting Wi-Fi, or I will be getting the cellular from the mobile phone. At the same time, if your device is only offering you a serial port, an Ethernet connection, then you expect a small IoT gateway to be used to connect the device. And this is, once again, something we need to understand. The other thing which is quite important when you select a wireless technology, is the device power, or is the device being used on batteries? And how long do you expect to run on batteries? If you say, for example, I expect my device, a sensor, to be live on battery for 5 years, 10 years. Let's take the city and the water meter, where people are looking at 10 years or 15 years. It's quite challenging to go with many technology. And it's reduced the scope of how many technology can fit the requirement. At the same time, is that a fixed device? Or is that nomadic, meaning, for example, factory floor? You want to reorganize your production line, and you are looking at flexible cell. It's clearly what I call nomadic. And then from there, you have on-the-move devices. So it could be a automated vehicle guide, or AGV. It could be a autonomous mobile robots, or AMR. It can be robotics, it can be a train, a subway, a bus. So once again, this is where we need to differentiate the device. And clearly, when we know that, we need to understand where you want to deploy and what would be the coverage requirement. If you are deploying that for distribution center or warehouse, it's a small location. It can be quite large, but it's a small location. If you try to deploy a solution along the track side, it can be 10 or 100 kilometers. And if you are looking at building a backhaul for nationwide deployment, then it may be 1,000 kilometers. So we need to understand exactly what you are looking at. The fact that is that fixed, the application running on top, and as I say, what kind of services you expect to use if you are on the move. So that's the reason we try to classify the requirement of the use case and look at two of the main requirements. How much bandwidth do you need? And what kind of latency do you need? And clearly here, I put few examples on the slide, because one of the keys when I look at the evolution of wireless, remember that wireless technology may start at few hundred bits per second. And I will be covering the LoRaWAN technology, for example. We start at 250 bits per second. And we go up to 21 kilobits per second for North America. Now, if you look at what we do today with cellular or Wi-Fi 5 or IEEE even AC, we can go up to, let's say, 800 megabits for spatial stream for Wi-Fi 5. But as soon as I need more than a gigabit, this is where everybody is now talking about 5G or Wi-Fi 6. And clearly, when you say data rate and throughput, the question is, why do you need throughput? And you may have two cases. The first one is you need high data rate because you want to deploy many devices, and you are sharing the throughput with all the devices. So that means the more you get, the larger number of devices you can put. At the same time, when I look at factory floor, we have industrial protocol where you may have dual radio and you want to send twice the same packet just to increase reliability and scalability as well. So that means if you have more throughput, you can put more devices as well. Or at the end, you may have, like, for example, today, if I look at, thermal camera for social distancing, a single thermal camera can go up to 250 megabits per second. And if I look at 4K, 8K, or even virtual reality with 360 degrees, that's something where I can reach a gig of throughput for one device. So clearly, the data rate is quite important to understand. Latency as well, but what is quite interesting is we have a good understanding of latency for wire, but as soon as you go for wireless, you may have interference. So this is where there are new mechanisms to look at how we can provide low latency. That's something we have been testing with Wi-Fi 6 internally to Cisco with an AMR use case, where with the reliability mechanism, we were able to achieve 3 milliseconds for latency on Wi-Fi 6. So once again, we look at the use case, we do measurement, and that's what we try to document as part of our Cisco validated design guide. So once you are done with the use case, the vertical, you can start looking at the deployment scenario. So this is where, once again, when you go wireless, you end with multiple kind of topology. So once again, I need to look, is that indoor, is that outdoor deployment? And outdoor, how large do you want to go? Is that a private or public services? Or what kind of spectrum are you using? Remember that when we say wireless, one of the fundamental of wireless is the license, the band you are using, the frequency band you are using. And that spectrum is so important. So here, I put some example of what we can deliver at Cisco. I'm pretty sure you heard about the recent acquisition of FreeMesh. It's not yet fully integrated, but what we have done, we look at expanding our scope of wireless connectivity we can provide. So that means we can provide point-to-point. So why do you want to do that? Let's say you have two buildings. Quite often you have two factories, two centers. The way you will connect the building will be using fiber. But now let's say you have a river, you have, the landscape is not good enough, or you have no fiber installed. So you can do point-to-point, you can go for point-to-multipoint, you can do a mesh or ring. So that means here we can provide communication. That's what you can do when you go for cellular services as well. The cellular services, now it's quite more complex because we are looking at larger deployment and broader deployment as well. So you will have a base station and the radio access network. The radio access network will provide connectivity as a star topology. And from there, you may connect end devices, or you can connect IoT gateways as well. We have star topology. That's something we see with technology like LoRaWAN, where you will get one gateway and you can put multiple sensors, and all the sensors will be communicating at the same time. You may have mesh topology, which is something we use for Wi-Fi, but we are also using mesh for what we call the field area network, or WISON when we deal with deployment, like smart metering, distribution automation, street lighting, for example. And then you have on the move. On the move is clearly the new use case for us with the acquisition from FreeMesh, where you may have the track side and the vehicle, and from there we are collecting the data. So let's take a look at where is it deployed and how we can deal with that. So clearly, one of the reasons it's quite important when you go for wireless, you need to understand where you want to deploy. The reason is each country, each world region has its own regulation. Even if you go for unlicensed band like Wi-Fi, unlicensed doesn't mean unregulated. It's strictly regulated. And that's the reason when you look at the number of Wi-Fi domains for access point, we need certification and we need to comply with all the regulation worldwide. And that's quite important. If I look, for example, at the product like the new radicalized Wi-Fi access point, the IW6300, we go country by country for certification. But we have customers who are global, and they have to make sure that we can deliver the product whatever the country where they will deploy it. At the same time, we need to understand the scale, how many sites, the technology you want to use, like unlicensed versus licensed band, and licensed band will be dependent country by country. And from there, the certification. Make sure that when we sell a product, we get the certification for not only for the country, but for the vertical as well, for the industry, because industries have a lot of certification. And we have to make sure that we comply with that. And that's really what we do. If you have to differentiate product from the IoT BU at Cisco from the rest of the enterprise, it's because we work on hardening, ruggedization of the product, and making sure that our product pass certification for all the industry vertical where we are selling.
Patrick, can I ask a question?
Yeah, sure.
Can you go back to the previous slide, please?
Yeah.
So from the scalability point of view, when you compare ISM bands, unlicensed ISM bands, and let's say licensed bands, can you talk about it? So can we say, for example, for the scalability, of course, interference is one thing, but scalability, actually, I wonder, any comparison can you do for that?
So if I could, I would like to answer your question when I will move to the Wi-Fi 6E slide, if you give me, sure. Because I think I will have an example. But clearly what I want to say here is when you look at how much bandwidth you can get from any wireless technology, most of the time you are looking at how many megahertz of channel width you can get. And this is where, if you really want to compare technology, I could say, for example, when I look at Wi-SUN for the mesh, for the wireless mesh, in North America, the ISM band is 902, 928 megahertz. It will give up 64 channel at 400 kilohertz. Now, when people are talking about 5G or Wi-Fi, on Wi-Fi, we look at the 20 megahertz channel, 40, 80, and now with Wi-Fi 6E, which is what I was willing to defer my answer, we are looking at the 160 megahertz and even 320 megahertz if I'm looking at the future of Wi-Fi 7. When you look at cellular, the question is, how much are you getting from your provider? How much bandwidth is a provider getting? Is that 20 megahertz?
Those wide bandwidths also, like when they come with the bonding, etc., they will be more suffering from interference, right?
This is where, once again, make sure we look at the channel, we look at how we can use it, where is that deployed? Because yeah. if you go nationwide, I mean, you look at how you don't interfere with the other. If you look at a deployment for factory floor, for example, you may be willing to restrict yourself to a given number of channels and make sure that you have application tools like spectrum analyzer and other where you can look at how is the band clean enough for that. So once again, it's technology dependent, location dependent, what is the need and how you use the tool to identify how you can optimize the deployment. I will come back on that with the Wi-Fi 6 slide, by the way. So I think
the previous slides that you just showed kind of walked through, how to select certain wireless design capabilities. Is the implication there that the Cisco portfolio covers every single one of those use cases?
I would say the Cisco portfolio will not cover all the wireless technology available on the market. I mean, you have tens of technology, and we try to focus on the main one. But the methodology we have developed, the framework, if you look at what I have said so far, I have not been picking one technology versus another one. What we try to do with the framework is say, let's take the vertical, let's take the use case, let's look at the need and the location and everything. And from there, at the end, this is where I am right now, let's evaluate what are the available technology on the market. And from there, yeah, for sure, at the end, if I'm working for Cisco, I will say, oh, this is what we can offer. And you will see one slide about what Cisco is offering. But the methodology itself we try to develop so far is independent from any technology and from any vendor.
So you are not saying LoRa versus Sigfox, etc.
Yeah. Not yet. At the end, I may be, for sure, when I will show the solution that Cisco is investing on, I will not be covering Sigfox because we don't have any solution on Sigfox, and I will be promoting LoRaWAN. But once again, the methodology, you can apply it by yourself. At the end, you can say, oh, here I need a low power wide array network solution, and the market, the choice is LoRaWAN on license, Sigfox on license, but managed services, or narrowband IoT from a service provider. So from there, once you have identified the technology because you know the use case, I would say it's up to the customer, the system integrator, the vendor to look at what is the best solution and put a price tag as well. Because there is, at the end, there is a cost of operation and the cost of material as well. And that's the reason with the methodology, we want to make sure that if you are willing to make a comparison, you get all the elements, and from there you can really make a comparison between different technologies. So if I go to the technology section, I split the section between, two chapters. The first one is make sure that everybody has the same understanding of spectrum. And the second one is more, let's take a couple of examples of technology. And this is where, to be honest, yes, I'm covering technologies that Cisco can cover. Otherwise, I will be presenting. So here, let's start with the spectrum section. On the spectrum section, as I said, today, we split spectrum between unlicensed, as you can use for Wi-Fi or Bluetooth, and licensed, what is most of the time used by cellular for service provider. There is something new, which is now share license, and I will come back later on that. But now, if you read the press about license, now the way the license is, the spectrum is split, people talk about sub-gigahertz, meaning below 1 gigahertz of frequency band, or what is called mid-band, which is between 1 and 6 gigahertz. And then now we have millimeter wave, which is what would be available on top of the 6 gigahertz band. What is quite important to understand is whatever the path you go, licensed or unlicensed, you have technology which has been specified for each of that. So if I look, for example, like the licensed band, sub-gigahertz, this is where you have 3GPP and cellular. You will find, for example, if I go to Europe, there is people looking at LTE 450 megahertz. You look at US, for example, you have now the 700 megahertz open, and I know people are looking at the 900 megahertz. If I look at the unlicensed band, it's clearly where you can operate the Wi-Fi mesh. You can operate LoRaWAN. You could operate Sigfox if you want. So this is what is covered by technology. If I go for the mid-band, meaning between 1 and 6 gigahertz, this is where, if I look at the license, this is where you have 4G, all the cellular, the 4G and the 5G new radio. And clearly, when I look at the unlicensed, this is where you can find Wi-Fi, but you find BLE, you can find other technology as well. And you will see I have a slide where I try to position everything. And then when you go on top of 6 gigahertz, this is where people are talking about 5G new radio for millimeter wave. And then you have also some variation of Wi-Fi as well, which may not be widely deployed, but that exists as well. So what is quite important is when you are at the sub-gigahertz, you have low data rate, but you have a very good signal penetration and long distance. And that's the reason quite often it's used for rural coverage, for example. When you are at the mid-range, you have good coverage, good capacity, good bandwidth. Now, when you go at the high end with millimeter wave, you have very high data rate, and that's why if I look at 5G, for example, people are telling you that you will get 10 gig or up to 20 gig of data rate, but very short distance. And that's one of the reasons with millimeter wave, we expect the number of antenna to be increased for deployment. So I talk about the fact that now there is what is called share license. So share license is typically what's happening today in North America, in the US, with the CBRS auction. So what does it mean? It means FCC has been opening 150 megahertz of spectrum. And this spectrum was already used. So that's the reason they characterize the spectrum in 3 categories. The first one is you have what is called the incumbent. People who were already using the frequency band. And that means if somebody is already using the frequency band in your location, there is no way you can use it. So example, it's satellite station, the US Navy. They own the band and you cannot interfere with that. Then you have what is called the PAL, the priority access license, and it's what the FCC is auctioning right now. I mean, if you go on the FCC website, you will see that there is an option. You have around 200 companies today who are bidding for that. So that means they will get a piece of spectrum and they will be able to deliver services for 10 years in the area where they are deployed. And then from there, you have the general authorized, meaning here, I want to use, let's say, for example, Cisco. I will take the Cisco example. When we were doing our CBRS testing in San Jose, what we have done, we deploy robots inside our warehouse. And what we have done, we apply for the license for the specific location of Cisco. And that's what is called share license. It's like a reserve band, frequency band. It's 150 megahertz of spectrum, but you can only use it in a given area, and you have to make sure that you register yourself. So normally, what is expecting to be deployed is what is called the Spectrum Access System, or the SAS, meaning when you deploy in a location, your system will register to say, hey, I'm using here the spectrum. So that, and right now it's clearly...
Patrick, before you go to these devices, can you go back, please? For the tier 1 license type, can, for example, mobile operators apply for that?
So not anymore, but we have mobile operator today applying for CBRS. I mean, if you look at the auction for the 100 megahertz, you will see a lot of small service provider applying license for it because they want to provide services in their area. Right now, you have service provider and utilities.
So they can apply for tier 2 or tier 3, but not the tier 1.
Yeah, not the tier 1. The tier 1 is people who were using the spectrum before. And what does it mean for a vendor like Cisco? What does it mean for a customer? Once again, it's a little bit like the Wi-Fi domain. When you want to go and sell a solution for cellular, you need to look at the band, the frequency band, and from there, what does it mean on the product? So I didn't look at, once again, I didn't look at the radio access network because it's not one of the business where Cisco is active today. But when I look at what we can do on the IoT gateway, for example, we want to make sure that our IoT gateway can be sold worldwide. And we have global customer, and we want to make sure that, let's say you deploy an IoT gateway on an airplane or on a boat or whatever, you want to make sure that when you are crossing territory and crossing region, you still use a gateway, and you don't have to replace the board as well. So that's the reason when you look at the portfolio, we have cellular interface, which can be used for a given region, like for example, and we are following the evolution of the industrial modem chipset. So in the past, we have chipsets that were only available for a given carrier in the US, like Verizon or AT&T or the other, like T-Mobile. Now, the fact is we can go with multiple carrier. So that means we have a single modem chipset and we can support multiple carrier. And what we can do, we can switch firmware on the need. And that means if you look, for example, at one of the modules we have, you can use a module in Europe and US, and it's just a matter of firmware. And then now more recently, we put on the market the latest module where we are nearly supporting all the band worldwide, including CBRS, including private LTE for Germany and other countries. And that means clearly if you want something where you can deploy whatever your location, that's what we'll put on the board.
This IR router is the IoT gateway function, right?
Yeah, it's an IoT gateway. I just took it as an example, but yeah.
I think we've seen this one in Tech Field Day Barcelona. It was last year. We've seen this one. It was working for very harsh environment, etc. Right? This one.
Yeah, that's correct. I mean, we have utility, we have connected road, we have financial institution, water, utility. So that's the kind of device. Once again, the device is running iOS XE. It can be doing SD-WAN, which is not the topic of today. But that's clearly how we, from the business unit, we take the best of the enterprise networking and we add what is important for the industrial IoT.
Last year, Team Sigeti, during Cisco Live Tech Field Day, He brought this one actually to our show, and we checked this device. Yeah, it's also very working for the very tight environment, harsh environment that I remember this.
Yeah, we can do -40 plus 60 or 75 degrees. We type tested the device up to 85 degrees. As you can see, as we are moving forward, I mean, with the new module, we know that for North America, FirstNet is important. I mean, FirstNet is a cellular network deployed by AT&T for the first responder and for public safety. So we have to make sure that our device can be used for public safety. As I say, we know that we have customers asking for gateway for private LTE as well and CBRS. So that's the reason we're adding the band. So I mean, the main reason I put the 1101 here was to illustrate what does it mean to be global? What does it mean to be able to provide one device for a customer with a multinational or whatever and be able to deploy whatever the technology. So here, for people would expect that 5G will be better. I don't have I mean, even when we launched the 1101, we say 5G would be supported on the platform. We don't have the interface yet. But I want to illustrate that going global for 5G will be exactly the same. When we say 5G new radio, once again, we will have to split between the sub-gigahertz, the mid-band, the millimeter wave, and dependent of the worldwide location, this is clearly where we have to make sure that we'll be supporting the right frequency band. And once again, what you can see on the market, you can see people will support sub-gigahertz and mid-band, but not millimeter wave, or you will see option where you will get not only the sub-6 gigahertz band support, but millimeter wave as well. And that will, where the throughput will be dependent. So now, this one is a very challenging slide to design. I was willing to say, oh, we spend time talking about licensed band and share license, but what's about unlicensed band? And how can I display the fact that you have the ISM band, but you have many technology using it? And you can see here, I try to put in green what Cisco can provide. I mean, this is the green is whatever solution Cisco, it's part of our portfolio. But I also want to show that what we can provide through partners, the blue one, like when I say, for example, Wireless Art or ISA 100, this is where we are working with partners like Rockwell, like Emerson, or
Zigbee.
Or Zigbee with partners. Yeah. And you have technology where Cisco is not doing anything. Like, for example, if I look at Sigfox, I mean, it was your question, I mean, fair question, good. You see that we, once again, part of the methodology process, I try to be neutral and show where the technology fits. And you can see from the slide as well, one of the challenges with the wireless is clearly you go from very low data rate. I mean, if I look at Sigfox, it's 100 bit per second. In Europe, it's 600. It's up to 600 in North America. If I look at LoRaWAN, it starts at 250 bit per second, up to 21 kilobit per second. And on the other end, this is where I have Wi-Fi 6, Wi-Fi 5, 6E, where I'm expecting to do more than a gig. So you see that's clearly the challenge of the unlicensed band, and that's the reason I try to, put a representation of the landscape today so you can get a good view of where we can use it. So we talked about Wi-Fi 6E. So what does it mean? So the first thing is when you look at Wi-Fi 6E, I mean, it's just Wi-Fi 6. The E is for extension. And the reason is FCC has been opening 1200 megahertz of spectrum to be used by unlicensed technology. So when the IEEE 8211AX works on the specification, they were aware of that. So what they have done, they specify Wi-Fi 6 or the 11AX, not only for 2.4, 5 gig, but 6 gig as well. So that means now when we say Wi-Fi 6, it's more the wireless alliance who's willing to put a brand on the expansion. So it's a new band. Clearly, today it was used by a few people, so it's a clean band. And you can see that you have new definition for the UNRI. But what is quite interesting with the band, with the fact you are getting 1200 megahertz of channel, is the fact that now the number of channel for 20 megahertz, 40 megahertz, 80 or 160 is quite larger than what we used to do. I mean, if you look at the Wi-Fi 6 to, let's say, Wi-Fi 5 today, you already have definition for 160 megahertz of channel. But you have only 2 of them. And out of the 2, you can really use 1 of it. And that's the reason today, when you look at the market, there are, I would say, nearly no device using the 160 megahertz channel of Wi-Fi. And that's clearly why Wi-Fi 6 is interesting, because now we are getting up to 7 channels for 160 megahertz. And even if some of them can be under what is called the spectrum allocation, meaning you may not be using them in certain location. Once again, it gives you far more bandwidth. And when we start saying, oh, we can drive Wi-Fi 6E up to 10 gig, and one single special stream of Wi-Fi 6 can be 1.2 gig, it's because, meaning one device can transmit up to 1.2 gig. That's because we are taking benefit of that. And by the way, if I start looking at other technology, we will see the evolution. So once we have got a good understanding of spectrum, now let's take a look at technology. And this is where, to answer the question, the good question, yes, I will be focusing on technology that Cisco can provide solution on the portfolio. I won't be covering solution outside of the portfolio of Cisco. But I expect that the methodology is good enough. So if you want to work with that, if you want to, I mean, if you were willing to promote technology which is outside the portfolio, then you can still use the same process. So let's review now the different technologies Cisco is seeing in the market. Clearly for us, when we look at Wi-Fi, this is the, I would say, ubiquitous technology for IoT. And the main reason is I can take any mobile phone, any laptop, any tablet, a robot, HGV, whatever, they're all coming with Wi-Fi today. It's Wi-Fi 5 or even other generation of Wi-Fi, but it's there. The good thing is when you do a network design with Wi-Fi, it's a symmetric boundaries. So you don't need to care about the fact that you have downstream or upstream. You are getting, it's a symmetric boundaries and you can send and receive at the same data rate. The other good thing about Wi-Fi for us is the backward compatibility, meaning we can deploy a new access point. It will support all the legacy devices, or you can deploy a new devices. It still connect with the older Wi-Fi generation, and that's quite important for us. And from there, you know that there is regulation, multiple domain, so that's the reason you can see multiple SKU. And we have still to comply with the regulation in terms of certification per industrial vertical. So when we sell to transportation on railways, when we sell to oil and mining, we have to make sure that we have product compliant with industry. What is quite important to understand with Wi-Fi as well, it's a live technology. So today we talk about Wi-Fi 6, mostly deployed by IT. We start looking at Wi-Fi 6E, and we know that in 4 years from now, 5 years from now, there will be a Wi-Fi 7. It's already under development by IEEE under the .BE. And this is where they want to take benefit of the 320 megahertz channel to go up to higher speed. So it's just an example of where we are with the Wi-Fi technology. Now, what does it mean for us to go Wi-Fi 6 for IoT? The challenge we are facing is today Cisco is offering Wi-Fi 6 access point. This is what we sell to IT. And when we sell to manufacturing, we are using the non-ruggedized AP from our friend in the enterprise networking. So that means here we can start deploying Wi-Fi 6 today. Now, when you look at industrial environment, we know that the life cycle is longer. And we know that we need to make sure that whatever the way we design product not only can be supported worldwide, but at the same time we look at how we can support all the industrial protocol. Like for example, if I say Profinet for manufacturing, I need to make sure that all the redundancy protocol from Profinet, if I say PRP or whatever, work well with Wi-Fi 6 as well. And we need to look at what will be the benefit, because most of the time the industrial applications are not consuming too much bandwidth today. So we have to make sure we understand exactly how we can provide the best of the technology. And that's the reason we are clearly focusing on Wi-Fi 6E. At the same time,
Patrick?
Yeah.
I've got a quick question regarding this. So if I read the slide correctly, what you're saying is that right now, existing industrial IoT equipment really doesn't get a lot of use out of Wi-Fi 6 and 6E because it's not optimized for AX bands, either in 5 or 6 gigahertz. And so, and the other thing you mentioned on the previous slide is that we don't even have a standard for that. We have what we think is going to be the standard. Do you anticipate there being some kind of a, I don't know, upgrade program is not the right word, but do you like a pathway for, like, if I go and invest today in, say, Wi-Fi 6 radio, that there's like a path that will get me to a 6E radio if I ever need that, like just to rip and replace a module? Or is this one of those things where I'm stuck with that equipment in that IoT device until I refresh it 4 or 5 years from now, when 11BE will be Wi-Fi 7?
Okay, so the first answer is if you have a Wi-Fi 6 product today and you expect the Wi-Fi 6E product, it's a new chipset. And chipset for Wi-Fi 6E are not yet available. So clearly, do you need to replace the equipment, or is that a new module? It's clearly dependent on the vendor and the equipment you will be using. That's the first answer. The second answer is when you look at industrial deployment today, quite often they are very long life cycle, multiple years. And that's the reason what we see people are adopting today Wi-Fi 5 or 11.AC. And the reason is because even their devices, the devices that do connect, are not even compliant, or using the bandwidth of Wi-Fi 5. So that's the reason we try to look at the approach to say, okay, what will benefit for the industry of Wi-Fi 6E? The data rate, you can put multiple devices, but at the same time, you also need to upgrade your LAN infrastructure. Because remember, if you have a Wi-Fi 6 AP, which can deliver more than a gigabit, and your Ethernet backhaul is still using 100 megabit or 1 gig, it may not be good enough. So that means, well, the way we look at the future development is making sure that we do provide switches. And in fact, I don't know if you have seen the announcement, but we just launched very recently new industrial switches with multi-gig port and 10 gig port. And what we said, this is the kind of switch you will need when we start deploying Wi-Fi 6 infrastructure. So we want to prepare and make sure that the path for migration exists. And we have to look at the full path. Not only the one of the elements versus all the other.
Thank you.
So I tried to put the same slide on the LTE and the cellular evolution, because for us, LTE and Wi-Fi, it's not one versus the other. Both coexist, and we expect that both will coexist for a long time. And even today, you can see service provider providing voice services over Wi-Fi because they don't have enough spectrum. So what they do is, when you have your mobile phone, for example, attached to your Wi-Fi network, you can reroute the voice call over Wi-Fi. So that's the reason we see good complementarity, and we know that people are deploying both. Now, the fact is, when I say cellular, it's not a single technology. Once again, it can be from very low data rate, 27 kilobits for what is called narrowband IoT, to LTE Cat M, and then all the category of cellular. And the other thing with the cellular is, remember that it's asymmetric most of the time, unless you go for time division band, like for example CBRS is time division, where you can split the band between two symmetric part. But remember that the cellular network has been designed to provide more downstream bandwidth than upstream. Like, for example, when I say category 3 LTE modem, a Cat 4 LTE modem, it means 150 megabit downstream, 50 megabit upstream. When I say Cat 18, it means 1.2 gigabit downstream, 150 megabit upstream. So once again, when you design your network, when you are looking at what kind of use case, you need to understand the way cellular can provide bandwidth, making sure that you have enough for both upstream and downstream. So on the slide here, I'm just showing what's the evolution of cellular. We know that 5G is coming. It's quite important. And you have to split 5G in two different, I would say, scope. The first one is a packet core, how the packet core will get virtualized. And that's quite important because if you look at low latency, for example, the user plane forwarding, meaning the data coming from your device and being switched on the, I would say, enterprise network, has to stay local. This is how we can achieve low latency. And the control plane can be centralized and it can be managed by the cloud. So that's clearly the packet core has its own evolution. But you have what is called 5G new radio. And what's quite interesting to see with 5G new radio, right now it's under the license band. And people are working on how to use unlicensed band as well for what is called 5G unlicensed. So what can you do with I would say, 5G evolution? The fact is, when you look at the 3GPP release, the latest release, 13, 14, they have been focusing on the low data rate aspect. And that means this is where you have seen narrowband IoT and LTE-Cat-M. And that's quite important. You want to connect a device which is not, which doesn't need too much bandwidth, but you need to care about power. And that's clearly where people are deploying the LTE-Cat-M. You can see LTE-Cat-M as being the replacement of GPRS or 2G. A lot of service providers worldwide, and particularly in the US, are now turning off their GPRS services. And that's quite important for people who have M2M services and subscription. What is the replacement? And that's clearly where LTE-Cat-M play a role. This is a low data rate. And 5G is not modifying anything here so far. And then the 4G evolution bring data rate up to Cat18, which means 1.2 gig. But now with the introduction of 5G new radio, this is how we can improve now the data rate. And by using the millimeter wave and using more spectrum, we can now improve how much data rate the service provider will get to cover a given area. So what can you do with this kind of, I would say, high throughput technology? The first one is what we call massive IoT. Massive IoT, let's say, best example, best use case for massive IoT is clearly a connected car. You want to connect all the car. That means on a given area, a square kilometer, a square mile, or whatever, the number of devices can be quite important. And that's how the technology has been designed, making sure that from a spec, you can reach up to 1 million devices per square kilometer or mile from there. And you may have very low data rate. You don't need a lot of bandwidth. And that's clearly one of the areas for what's called the massive IoT. And the question is, what do we do here at Cisco? Clearly, the first product, if I was looking at the Cisco solution, this is what we call Cisco Control Center, where you do authentication and management of SIM card. And that's clearly where we do provide the services, the platform to service provider. So now we can manage such large number of devices and SIM card. So the second aspect of 5G, which is quite important as well, is what is called the mobile broadband or the high data rate. What does it mean? It means here now I can get up to a gig of throughput, or if I have many users, let's take a stadium, for example, I will be able to offer more throughput to the end user. So now if everybody's streaming video, I can get, the throughput for the video. What is quite interesting here is today, what kind of technology can you use if you want to get a gig of bandwidth at home? You need a fiber, or you need potentially cable. So here, by providing high data rate, it provides the opportunity for mobile service provider to deliver services at home as well using 5G. So that means in location where the cable is not good quality or very long distance, now we can increase the services that the end user will get. And then what is under definition now for the next gen of the spec is what is called the ultra reliable low latency communication. So that means here, the spec for 5G is, how can I guarantee that the latency will be between 1 and 10 milliseconds with determinism access? And that's something, now it's quite challenging because Cisco has been working on what we call deterministic network with Ethernet for years. And I will see it's still a small market for us. But so people try to replicate what has been done for TSN, the time-sensitive network, on wireless, and that's clearly the goal of the URL. But what does it mean? It means you may be the network operator, may be doing slicing, meaning offering a given piece of spectrum to an enterprise. For that, it means you need to make sure that the user plane forwarding is the nearest of the application. And that means edge computing. And I'm pretty sure that, I mean, as you have been participating to previous field day, you heard about edge computing, edge intelligence, IOX, how we can bring for industrial IoT compute resources next to the devices. That's clearly what 5G is looking as well with the multi-access edge computing, because that's how we can reduce latency for the network. So why, I mean, quite often today people are now thinking about private LTE and private 5G. So what we try to evaluate is who is willing to deploy that, because you still need to manage a packet core, you still need to put your radio network. So we have been looking at identifying the different vertical. And in fact, if you look at the FCC auction for CBRS, you can look at that. And we particularly look at the use case. We see oil company, for example, they are willing to go for private LTE, oil or mining, because they are not getting any services in their area. Let's say you are in the Gulf of Mexico and you have an offshore platform. You may not be getting cellular services. You may be in a very, I would say, metallic environment where if you want to cover the full area using Wi-Fi, based on the transmit power consideration of Wi-Fi, you may need a lot of access point. And one of the difference between Wi-Fi and, for example, CBRS is the fact that when I look at the CBRS regulation today, your base station can transmit up to 1 watt of transmit power for indoor. So that means the coverage will be better. I mean, it's a matter of transmit power. And you also want to offload traffic. So there are good reasons to go for private LTE. And from there, we try to look at, okay, but what does it mean? How do you get the spectrum? So some country, like in North America with CBRS, you have shared spectrum. Some country like Germany, for example, you can buy spectrum. I mean, there are a frequency band, which is a subset of the CBRS one, where you can pay for it and you can use it locally for whatever you want. You have to decide, are you willing to deploy your network, the network yourself, meaning the packet core, the radio, the authentication system, or are you willing to go for managed services? When you do that, is that a network that is completely isolated, or do you need to provide roaming capability because now you want to make sure that you can switch from your network to a service provider network? And you need to think about what does it mean in terms of security policy, management security policy, automation, training. So that's really what we try to define. And the reason is because when we look at what you are looking for, I mean, when you go for private 5G LTE, as I said, it can be fully private, it can be managed, depending on what you are doing. But you need to deploy a packet core with a control plane function. You need to deploy the packet core with the user plane function, as close as the people. You need to deploy the edge computing, and you need to deploy the authentication system, and you need to deploy the devices. So that's really why, once again, it's quite important when we look at the full solution for wireless to look at what does it mean in terms of cyber security, automation, and everything. So I don't want to spend too much time on technology like Laura, unless you have questions. Here now I'm switching at the other end of the spectrum where you can connect endpoint, which are non-IP, transmitting packet maybe one every hour or something like that. Very slow traffic, high latency. I mean, don't expect maybe, I mean, what you can do is LoRa, you can go maybe one packet every 15 minutes. If you are, when you go through the framework methodology, if the requirement is, I want to send a packet every second, every 10 seconds, or every 15 seconds, forget about LoRa. It's not for this use case. So that's really what we try to show here. And you need a centralized controller, we need the network server, and that's what we can provide. The mesh, the Wi-Fi mesh, is clearly something we have deployed for utility. So the use case is smart metering, distribution automation, street lighting. We go for oil and mining as well, where we can do oil well. What is quite interesting here, the endpoint is an IPv6 endpoint. So today, the reason I put the slide on my presentation is at Cisco, we have been working with partners for the endpoint because we don't provide the endpoint, but we have something like more than 15 million IPv6 endpoints deployed in North America. And we have platforms like Field Network Director to manage that. And I think that's something unique in the industry. It may be a limited industry, but it's a large volume. And when you know how to manage 15 million of end device, that's become quite interesting challenge. And I talk about the specific wireless art and ISA 100. Once again, this is a typical example of technology we don't do by ourselves. I mean, Cisco is not doing anything on wireless art or ISA 100. What we have done, we have been working with partners like Honeywell or Emerson, and at the same time, we allow the partner to integrate their technology, their radio technology, on our Wi-Fi access point for industrial. And we also document what are the best policy for coexistence between different radio. So it just shows an example of how we can coexist with multiple radio. And the last slide clearly is once you are done with the methodology, I'm back to methodology. This is the last step. Once you have done your selection for technology, maybe for a given use case, you may end with, let's say, one or two, let's say two technology. So now the question is, which one do you want to go for? And this is where we need to look at the operational side of the story. Like, for example, are you willing to go for on-prem deployment or cloud-based? And it could be private cloud as well, but private cloud for me is on-prem because you need to own the product and deploy it by yourself. You need to look at the country data policy. Like, for example, in Europe, we have GDPR. So that means you have to make sure that the cloud services is based in Europe. What is your system integrator? Within the network design, are you looking for CapEx versus OpEx? If you need to pay for spectrum, that's something you will need to pay regularly. So once again, it's OpEx. The backward compatibility for the device, the project timeline, because we know that technology is evolving. So what is the next gen? When do you want to deploy? What kind of, device? And by the way, you need to train people. And you need, one of the ways to evaluate the technology as well is to look at the ecosystem. How many devices can you buy on the market today for a given technology? And that's quite important because this is how the price is going down. It's because you have competition and you have more and more devices supporting one given technology. And that's why the technology is popular. At the end, forget about technology where there is no use case, or forget technology when there is no devices. Clearly, we need a strong ecosystem to make a wireless technology being successful. What are we doing at Cisco? We try to cover different technology, and the slide will be shared, so I don't want to spend too much time, but clearly the goal of the IoT business unit at Cisco is to provide the best set of product for different technology. So once we go through the framework, the design, we can go to the last step and say, oh, by the way, here, this is what Cisco can provide as a product. And clearly you have the full solution. So from the IoT gateway to the routing, the Wi-Fi, the LoRa one. But what is quite important is to look at what are customers deploying today. And clearly here, when I look at the main industry verticals, from manufacturing, utility, smart city, mining, and so on, I can see that there is no single technology fitting all the requirements. I can see customers deploying different kind of technology. And that's clearly what we see today on the market. So That's the reason, and that's the last slide. We think that there is no single technology fitting all the requirements. We think that there is a need for to provide a framework so people, partner, customer, the field can go through the analysis and make sure that they can understand how to build the architecture. And that's why the Cisco validated design guide process is important for us. And when we look at what we can provide, we are not pushing customer to go only for one technology. We try to provide all technology in the context of the network, meaning how do you connect using the wire, because you can be using wireless, but somewhere there is wire as well. How you do under automation, management, and cybersecurity. And that's clearly the way we look at technology for us. If you want to look at what we have done, because we try to learn ourselves, what we have done, quite recently we acquired a robot, an AMR, and we have been using the Cisco warehouse to test and validate Wi-Fi 6. So we put a Wi-Fi 6 prototype on client on the device. We put CBRS as well. And the next step is to do 5G. And from there, we can do a comparison, technology per technology comparison, which is quite important because once again, when we are willing to provide data to customer or partner, we want to provide real data. And that's the reason. And we did a short video that is now on YouTube, and you have the link here because I blog about it. And the last one is, if you have interest for that, we have blogs, you have resources on the Alliance, and that's what we have done. So I want to thank you for your time. And if there is any question, please.
So Patrick, it was really good, by the way, presentation. I really enjoyed a lot. Hopefully we see more IoT sessions in the tech field there, by the way. So, but we didn't mention, for example, routing over low power, lossy network, etc. It's a standard, and I'm sure Cisco supports on more than one device, right? So, can you maybe very fast, can you mention about Ripple?
About Ripple? So, yeah. So what we have done is Ripple is originated from Cisco. I mean, I would say, I used to work for Cisco. I was if I look at my history, my background, I used to be the first IPv6 product line manager at Cisco for iOS. And I left Cisco for a startup called Archrock. And the Archrock was a spin-off from Berkeley University. And one of our tech lead engineer was leading the Ripple development at the IETF. And we had a Cisco engineer as well, co-sharing with him. And we got acquired by Cisco. We got acquired by Cisco, so I was back at Cisco.
I think Pascal is working with Cisco, right? I thought
Pascal is working at Cisco, but we have Jonathan Hui. Jonathan Hui, you can see Jonathan as a co-author of the 6LoWPAN and Ripple RFC. So clearly, when we got acquired by Cisco, with the objective of developing the Wi-Fi stack. And the Wi-Fi stack is clearly where we do implement Ripple for the first time. So product like the Cisco IR510, 509, CGR1240, this is where we are running Ripple. And as I say, today we have over 15 million endpoints deployed. That means we have more than 15 million endpoints running Ripple today on Cisco, based on Cisco software. So that's what we have done with Ripple so far.
No, exactly. I agree with that. Cisco is doing a great job, especially on the routing side in IoT. And I knew that so many millions of devices already on top of Ripple with the Cisco devices working. Great job.